what is the difference between sketching, drawing, and constructing? Sketching is doing it by freehand, kind of just eyeballing it and sketching it with your hand without the use of any tools other than your hand and a writing utensil. Drawing is where we actually use measurements. And what are some tools that I would use get measurements from? For distance, what's one of them? A ruler. What would I get measurements from for angles? Protractor. So if I say, hey, draw a congruent angle, you'd need a protractor, and you'd make a ray, and then measure the angle in the protractor and make your other ray. That's where I use the ruler or protractor and measurements. Which of those is more accurate? Drawing. Constructing is where I use a ruler, but I don't really use it for measuring. I use it as a straight edge so that I get straight lines, and I use a compass, which can lock in exact distances. So the problem with using a ruler is, what if I'm off? What if instead of being 4 inches, 4.5 inches, it's actually 4 7/16 or 4 9/16? Then I'm off a little bit, right? It's not as accurate. Where the compass will lock that exact distance, and it'll be precise as long as my compass doesn't shift when I'm using it. So if we're looking at this as a continuum of things that are accurate versus not accurate, this is the most accurate, assuming that your compass is being used correctly and is locked. That is the most accurate, and freehand is the least accurate in terms of having a visual representation. Freehand is great. We do it all the time in geometry to sketch pictures and get an idea of what it's going to look like, but it's not going to give us an accurate drawing or something that's to scale. Drawing to scale can be good if we have measurements. Constructing is more precise though than that. So in this next problem, in our first problem, it says sketch a segment congruent to MN, and that's where we're supposed to do it freehand. And so I'm just going to put a point down and put another point down about where I think makes them congruent. And I'm not going to call it M, I'm going to call it X and Y, but you can call it any other letters. Don't use M and M though, because those points are up there. And then I just mark that they're congruent. Now, you can see my line isn't very straight. Like, I did what I could, but it's not perfect. And it's probably not, even if I measured it, not even the same length. But they're close. To do this, to draw them to be congruent, means that I need to use my ruler. Now, some of you are good at using inches, and you're good with 1/16 of an inch and 1/8 and quarters. Most of you probably are not. So we're going to stick to centimeters, because we can use centimeters with millimeters, just with the decimal. And when I put this down, I'm getting it to be 4 centimeters. Maybe you get 4.1, depending on how you look at it. And so I plot those and connect them with a straight line from the straight edge. This is more accurate than what I have above in the purple. They probably are closer to being congruent, but they may not be exact. Lastly, I'm going to construct, and each of you should have 1 compass per desk that you can share with the person sitting next to you. There are some extras in that back table, so if you're at a desk where there's a lot of people, like there's a full table there, feel free to help yourself to one of those. Just put it back when you're done. Constructing a segment congruent to MN requires me to use my compass. I'm going to start by putting a point down, I'm calling it X, and I'm going to lock in this exact distance. Now, I don't have the sharp point that you have. The part that's highlighted in orange, I'm going to pretend is my point. I'm going to drop that down on M and drop this down on N and make sure it's right at those points exactly. And if it is, then I can drop my point on X and do a small curve. Any point on that curve should be the exact same distance from X as m is to n, as long as my compass didn't move. So I can connect this point to any point on that curve. And the distance from x to y is congruent to the distance from m to n. mn is congruent to xy. And that is exact, because my compass gave me the exact distance. Yes?
I don't understand.
Which part?
The part about like the compass. How to use the compass so it.
We're going to add a little twist to this problem in that I'm going to give you a segment down here, and I'm going to measure mine to be 4 centimeters. You can measure it whatever you want, just make sure it's straight. I'm going to do 4 centimeters, and I'm going to call this CA. Oh, you can't see that. That might be helpful. I'm going to call that CA. And what I'm going to do is I want to construct CT to be 3 times the length of CA. Construct CT to be 3 times the distance from point C to point A. Now it doesn't say draw, so I shouldn't be measuring and using my ruler to measure out units. I should be doing something with my compass, locking that distance, and then making sure I have how many of these distances? 3. But I also have to make sure it's on a straight path. So I'm going to actually, instead of dropping a point where I'm just making a congruent segment, I'm going to extend this line well beyond what I think. Oh, that's not very good. I'm going to extend that line well beyond what I think I need. And now I'm going to set my compass down and lock this distance. I got to get it precise. Might have to move your compass. Lock your compass though. Try not to touch this part. Only touch the part that has the peg once it's locked. And I'm going to do a small arc here. So now this point is how much bigger, how much is C to this point compared to C to A? How many? 2 times bigger. And now I'm going to drop my point, the sharp point, onto that point and do another arc. And now this point right here is where I'll put T. So that CT is 1, 2, 3 times the size of the original segment, CA. Try doing one more construction of congruence, but we're going to move on to midpoint soon. If everybody at your table has done at least one of these congruent structures, which are pretty easy and straightforward, the next thing I'd like you to try to do is to make a perfect circle. And my tip for that is you don't put any pressure on the pencil. You don't hold the pencil, you don't touch the pencil. You touch, this is my sharp point, only the sharp point of your compass. If you're grabbing it from the top, you're going to spin from only that point on the compass that you're holding down. And you're only going to apply downward pressure on that sharp tip. You don't want to put any pressure on the pencil. You just want it to lightly go across your paper, just enough that you can rotate it or twist it with your thumbs while you're pushing down to make a perfect circle. Technically, you don't, that's what you want to do with your paper standing still. If you still struggle with that, don't grab the pencil. If you grab the pencil, it's going to move and the distance is going to change. You won't have that distance locked. If you still struggle, you can hold down at the point and hold it closer to the point with downward pressure on the point and put your pencil down and turn your paper. You're not supposed to do it this way, but if it gives you a perfect circle and it's easier than twisting it at the top, you're welcome to do it that way. Make sure you can do a perfect circle before we go on to the next construction. If you need help, I'll be by to help you in a second. I just want to pause this real quick. Midpoint. Construction of midpoint. Step 1 is actually, where do you guys think the midpoint is roughly? In the middle. if I make my compass go to the middle, I'm not going to be able to complete this construction. I actually have to make my compass a little bit bigger than where I think the middle is. So step one is to lock your compass a little past the expected midpoint. Wherever you expect the midpoint to be, lock it past that. So here's my stabbing point on my compass. I put it down on point X, and I'm in luck. Mine's already bigger than where I think the midpoint is. If it's not, I'm going to pull it out and tighten it up so that it is. Step two is to make a semicircle from the first endpoint. Make a semicircle above and below the first endpoint. Semicircle above to below, or below to above, I don't care, an endpoint. So I'm going to stab point X and keep my compass there with downward pressure. I'm either going to spin my compass, or some of you like to turn your paper instead. So it's very faint, but there's a semicircle from below that endpoint to above that endpoint, or maybe you start up here and go down. Now I'm going to repeat this semicircle from the other endpoint. If you're trying the construction right now, you can write the steps down when the next person tries. So I'm going to, and I'm going to spin my paper this time just because I don't have a real firm point. I don't want to twist and have it fall off. All right, so I've got my other semicircle there. I wonder how I'm going to get the midpoint now that I have those two arcs.
You see what I covered?
Oh, what do I do? Sing la la la, connect the dots?
Yeah.
Wait, these two arcs intersect here and here. So I'm going to connect the intersection points of the arcs. And that is going to create a segment bisector. The reason why every point on this line is equidistant from X, every point on this arc is equidistant from Y, and where they intersect has to be the middle. And then I'll label my midpoint. So there really kind of is another step. We'll label the midpoint and show that those arcs are congruent. Please practice this at least one more time. After you've tried it initially. If you're not getting it correct, I'll be by in a second. There are two more constructions that we need to cover. We're going to cover at least angle bisector today. We might have to do congruent angles later. Angle bisectors. Like constructing congruent segments and midpoints, you will only have to lock your compass once for this. When we get to constructing congruent angles, you're going to have to change the setting on your compass. That one's a little more tricky. For right now, we're going to step one, which is lock your compass and make an arc from the vertex that touches both rays of the angle. So we're going to do an arc from the vertex. It must touch both rays of our angle. If it doesn't do that, then it's not going to work. So I'm going to decide I want my compass to be locked so it's at least halfway, maybe a little bit more than what's going to touch the two rays. If it's too big and it doesn't touch them, then I have to extend them. That's the pain in the butt. If it's too little, it's too tight to work with. So I'm going to open it up so it touches at least both of them. Okay, and it doesn't have to be a full circle, but it can be if you want. That is the first place I put my compass, so I put a little 1 next to the vertex. The next step is to label the 2 points where that arc touches those rays, and we're going to call them point 2 and point 3. Label the intersection of arc on rays. We'll label it 2 and 3. Those are our next pivot points for our next 2 arcs. Step 3 is to make semicircles from points 2 and 3 separately that touch the rays. So if I'm doing this, I'm going to now, with the pointer part of my compass, I'm going to stab point 2, and I'm going to make a semicircle that starts at the vertex and connects all the way back to the other part of the ray. It might not touch it if my ray is too small. Now this is really faint, so it's hard to see, but there's an arc, a semicircle going from here all the way over to here. If your ray wasn't that long, it wouldn't go there, but that's okay. It would still be close to there. So I did that from point 2. Now I have to do the same thing from point 3. Put the pointer from your compass on point 3 and spin your compass to make a semicircle onto that ray. From the vertex onto that ray. So that went from here up here. It went past the ray, but that's okay. The biohazard symbol? Not quite. How do I know where my angle bisector is going to be? Where the 2 arcs intersect, which is right here. I have one of my arcs. I'm sketching over it. Don't do this on the BA, but I'm doing it to darken it so you can see it, because it's hard to see on this projector. That's where the 2 arcs are intersecting, and there's my vertex. And so that ray right there should cut the angle into 2 equal parts. I could measure them with a protractor, and they should be, but I shouldn't need a protractor because this should be exact as long as my compass stayed locked from the very beginning and didn't move on me. Please try this at least twice to make sure that you can do it. I'll come by if you need help with this construction. This concludes the construction notes for now. We'll have to do a separate instance for constructing congruent angles. Have a good day.